Welcome to our channel Learning Math. In this video, we're going to learn about transforming rational numbers into fractions. Let's start together by the first example. As you see here, we have 12.034. It has a finite or terminated decimal part. As you see, we have 3 digits in the decimal part. How to transform it into a fraction? We just write the whole number without the point. So it's 12,034 over how many digits are in there in the decimal part? 1, 2, 3. So it's over 10 to the power 3. The power of 10 should be exactly equal to the number of digits in the decimal part as you see here. Another example, 0.0057. We have 4 digits in the decimal part. It's a decimal number having terminated decimal part, so it can be transformed into a fraction. Well, how to write it? We write the whole number without the point. So it's 0.00057 over how many digits in the decimal part? 1, 2, 3, 4. We write it over 10 to the power 4. Well, as you see, 0 on the left are not considered, so we can cross them. It's 57 over 10 to the power 4. Well, what about numbers having infinite periodic decimal part? Here we're going to learn some tricks about them. They are very important. If we have, for example, 0.7 bar, which is 0.777, how to write it as a fraction? The unknown for us is the fraction. In general, we name the unknown as x. So let x be this fraction. So x equals 0.7 bar. Well, to understand it more, 0.7 bar is 0.777. Here we're going to learn something. It will be 7 over 9 directly. We can write it, but here we will learn how did we get it. Now, why is 7 over 9? We have one digit in the periodic part, one digit repeating itself, so it will be 7 over 9. Well, let's prove it together. Actually, x equals 0.777. How many digits repeating themselves? One digit. So it's times 10. Well, we multiply it by 10. Why? We want to get rid of the decimal numbers. How to do this? Here, one digit in the periodic part, we use 1, 0, so we multiply it by 10. Well, we multiply x times 10, 10x. Then we move the point by one digit. Since we are multiplying it by 10, we move the point one digit to the right. So 10x equals 7.777. Well, you may tell me we didn't get rid of the point. How to solve right now? We just pick up this 7 alone. So it will be 10x equals 7 plus, instead of 7, we put it 0. It will be 0.777. Well, here we also didn't get rid of the point. But if you note something, 0.777 is exactly x. So we can just replace 0.77 by x. Now we can write it 10x equals 7 plus x. Here we got rid of the point. Now it's just an equation. We can solve it to know the value of x. So 10x equals 7 plus x. Now we just move x to the other side of the equation. Plus x becomes minus x. So it's 10x minus x equals 7. Now we just subtract them as if it's 10x minus 1x. So it will be 9x equals 7. Now how to find x? We move 9 to the other side of the equation. As you see, we have nothing between 9 and x, as if it's times. When we move it, times becomes divided by. So x equals 7 over 9. Well, here we can say that 0.7 bar, which is x, is exactly equal to 7 over 9. What happens if we have two digits in the periodic decimal part? Let x equal 0.34 bar. It's 0.3434. As you see, how many digits are repeating themselves? Two digits. So we multiply it by 100. We use two zeros. Well, so 100 times x is 100x Also, we move the point by 2 digits since we are multiplying it by 100. Sure, we move it to the right since multiplication. It will be, the point will be here, so 34.3434. Again, we isolate the number preceding the point, so it's 34 plus, instead of 34 we put it 0, so it's 0.3434. So 100x equals 34 plus what? Isn't it here exactly x? So we can just replace it by x to say that 100x equals 34 plus x. Now we solve this equation. We can say that 100x equals 34 plus x. We can move x to the first side. We group the unknowns together. So plus x becomes minus x. 100x minus x equals 34. Well, 100x minus x, isn't it 99x? So 99x equals 34. Here we have times between them. When we move 99, it will become divided by. So x equals 34 over 99. Note something. Two digits are repeating themselves, 3 and 4. How many 9 are we having? 2 9. So it's 34 over 99. So here we can say 0.34 bar equals 34 over 99. Something very important. We can write it directly. 0.34 equals 34 over 99 only in case we are having 0 in the integral part. Well, what happens if we have in the integral part numbers other than 0? Something very important. Here we should isolate the integral part alone and the decimal number alone. So it will be 1 plus 0.04 bar here. 0.04 bar is taken x. Well, two digits in the decimal part, it will be 04 over 99 means 4 over 99. Well, let's solve it together. Let x equal 0.04 bar. Well, how many digits in the decimal part? As you see, a periodic part, 0, 4, 0, 4. So 0 and 4 are the digits in the decimal part. We have two digits repeating themselves. We need two zeros, so we multiply it by 100. Now 100x equals, move the point by two digits, 1, 2. So it will be 04.04. Sure, we can cross 0 on the left. So 100x equals 4.0404. Now we can isolate this 4 alone. Look at it, please. So it will be 4 plus 0.0404. Isn't it x? 100x equals 4 plus x. We solve the equation, to get the value of x, which is 4 over 99. Well, something important. We have the question 1.04 bar, not 0.04 bar. So we need to add it with x. Again, if you look at it here, it was 1.04 bar. So we should write it as 1 plus x to solve. 1 plus x, now we're going to solve it. 1 plus 4 over 99, we transform into same denominator. We don't have denominator, so it's over 1. We multiply it by 99. We multiply numerator, same as denominator. Now we solve adding fraction. So it's 99 over 99, as you see, plus 4 over 99 to get 103 over 99. Finally, a very important special case. If we have, for example, 1.07 bar, how to solve such a question? As you see here, only 7 is the periodic part. So it's 1.0777. How to deal with such number? We need to isolate the periodic part alone. We don't need this 0. So in this case, we multiply it by 10 to get rid of the 0 to the integral part. When we multiply it by 10, we will get the answer. We move the point by one digit, so it's 10.777, which is 10.7 bar. Here we can start solving. So 10.7 bar, which is exactly 10 plus 0.7 bar. Here we have isolated the periodic part alone, and also we have 0 in the integral part. We can directly write it as 7 over 9, or we can solve it, which is here 0.7 bar. We can replace it by x, so it's 10 plus x. Now we solve it. The x equals 0.7 bar, which is 0.777. We multiply it by 10 to get 7.7. Now we isolate the integral part alone to get x again. So it's 7 plus 0.77, which is x. So 10x equals 7 plus x, as we have solved before. Now we can get it, x equals 7 over 9. What about 10.7 bar? Isn't it 10 plus x? So 10 plus 7 over 9, we have adding of fractions. When we don't have denominator, we can directly write it as 10 over 1. Now we transform into the same denominator, so we multiply 1 by 9. Also we multiply the numerator 10 by 9. So it will be 90 over 9 plus 7 over 9, which is 97 over 9. Well, something very important. They have just asked us not about 10.7 bar, but about 1.07 bar. Now we should transform our answer into 1.07 bar. We multiplied it by 10 to get 10.7 bar. To return it back, as we multiplied by 10 here, we should divide again by 10 to get the main answer. So now we're going to divide 10.7 bar by 10. As you see, we move the point one digit to the left, which will give us again 1.07 bar. Now we just divide our answer 97 by 10. So it will be here divided by, it becomes times. Here 10 is 10 over 1. We reverse the second fraction to become 1 over 10. Sure, the first fraction 97 over 9, we copy it the same. Now we just multiply them numerator by numerator and denominator by denominator to get 97 times 1, which is 97 over 9 times 10, which is 90. Thank you for watching. If you enjoyed this video, please like, share and subscribe.